When we solve systems, sometimes we end up with these special cases, the no solutions, the all real numbers. Let me show you how they work through in terms of the elimination method. So here's two equations, both in standard form. Looks like a nice system we could solve by elimination. So let's see, I'm looking at these coefficients. Maybe I choose to eliminate the y's first. Doesn't matter which one, but I'll choose the y's. So I need to get those to have the same coefficient, so I will multiply that top equation through by a -2, which will give me then -4x minus 2y equals -2. So now I can eliminate those y's. But the weird thing that happens here is that not only am I eliminating the y's, but also the x's get eliminated. So both of those variables, the x and the y, get eliminated, and I end up with 0 equals -5. So again, this is one of those not true statements. 0 is not equal to -5. That's one of our no solutions. Okay, if you recognize it right away, that the first thing you look at, that 2x plus y and the 4x plus 2, that one is twice the other, it's going to be a no solution as long as these numbers are different. Okay, so no solutions, they show up sometimes. Here's another system. We have -3x plus y equals 4, -12x plus 4y equals 16. Again, both in standard form. It might do us well to get rid of to use elimination, get rid of one of those variables. I'll try getting rid of the x this time. So I have a -3 and a -12 in front of the x. Maybe I'll multiply that top equation through by a -4. The reason I use negative is because now I'm going to have a positive 12x minus 4y equals -16. So the fact that I use a negative was to create an opposite sign to that -12. And now I can add those two equations together. But again, like in the last one, both the x's and the y's eliminate here. But also, the constants, we have 16 and -16. That's also 0. So this is one of those cases where we get a true statement at the end, and our true statement tells us there will be infinite solutions to this system of equations. In other words, if we put these in slope-intercept form, we would have in both cases y equals, I believe, 3x plus 4. That's the same line. They lie on top of each other. There are infinitely many ordered pairs that would solve that solution. All right, and that is it for these special cases.